We begin today with the new unit that encompasses the concept of probability. And today, the first lesson, we're going to go over some of the basic aspects of probability and keep building on that as we go along. Now, when we're talking about probability, the probability of an event is the measure of the likelihood or chance that a certain event, a particular event, will occur. The probability is a number from 0 to 1, and it can be expressed as a decimal fraction or a percent. Just so that you understand, a probability of 0 is an impossible event, meaning it's something that cannot happen under any circumstances. Not that it's remote, but it's impossible. So, for example, rolling a 7 one time on a single die is impossible. It only goes from 1 to 6. A probability of 1 is a guaranteed event. So if, for example, somebody came to our classroom and chose one student at random to go with them to the office, the probability that would be an 8th grader, okay, would be guaranteed or 100% because in that classroom all of the students are 8th graders, okay? Now, an outcome is the result that occurs after an experiment. So, meaning choosing a card, tossing a coin, rolling a die. The outcome is what happens. I got heads, I rolled a 3, I got a king of clubs, etc. Okay? Complement is the chance that an event will not occur. And an event and its complement add to 1. So, for example, if it's a 30% chance of rain, then the complement to that is a 70% chance it will not rain. Okay? It's got to be one or the other. The sample space is the set of all possible outcomes. So in other words, in rolling a die, the sample space one time is the numbers 1 through 6. Okay? Now, the theoretical probability is the number of ways, is the ratio or fraction of the number of ways a certain event can occur to the number of possible outcomes. The fraction that we write for this is the P of E. P standing for probability, E is the particular event that we're talking about. It's the number of favorable outcomes to the number of total outcomes. Okay? And one of the things to keep in mind that we're talking about here is that when we're talking about probability, we're not talking about odds. Odds are a comparison of favorable to unfavorable outcomes. Okay? So, in other words, the odds in favor of doing something would be the number of favorable outcomes to the total number of unfavorable outcomes, not to the total number of outcomes. So odds and probability, while related, are not the same computation. The other thing is, in all of these events, there has to be no bias, meaning there has to be no situation that's going to let one thing occur happen more likely than the other. Okay? All right. So I want to determine the probability of each event. I toss a coin once. The probability it comes up heads, 1 out of 2. I roll a die one time, and the probability is greater, a number greater than 6. It's impossible. I spin a spinner that has the numbers 1 through 6. The probability it's an even number, 3 out of 6. Now I want to stop there because one of the things is in probability, you are not required, I will not require you to simplify the number or fraction that you get. unless the question says expressed in simplest form. And the reason is just because when the number is written in the way it is here in blue, it's telling me some more information. It's telling me there's 6 possible outcomes. 3 of them are favorable. All right. If I simplify it to 1 out of 2, it doesn't tell me that. All right. It just tells me the relative probability. I pick a card at random from a standard deck of cards, and it's a club. Well, there's 13 out of 52 clubs. The probability, the complement of the probability in event 2, that's 6 out of 6. And what that means is that's the probability of rolling a number that's not greater than 6 or less than 6. The complement of number 4, 39 out of 52. Okay? All right. Now we go to the second example, a gumball machine with 5 different colors. And I want to find the probability of each of these when I select one gumball. Now, again, this is the type of situation where I'm talking about no bias, in that all of the gumballs would have to be the same size, shape, etc., because then that could lead me to choosing one over the other. So I add up all my gumballs, and I have 120 of them. So 120 is always going to be my denominator, and my numerator is just whatever that event is. Green, 20 green. Complement of green, 100 to 120. The complement of orange, well, there's 5 orange, so 115 out of 120. So how many orange? 5 out of 120. Not a color in the flag of the United States. So that means it's got to be green or orange. So 25 out of 120. Red, white, or blue, 95 out of 120. Okay? Now, the second type of probability is what's called experimental or empirical probability. And basically, the only difference is that this probability is based upon events having occurred, and that those events tell us or are basis for the probability of future events. So, in other words, we have a situation where somebody had spun a spinner, say that 3 times fast, and the spinner has red, green, blue, or yellow. And they had 5 red, 9 green, 3 blue, and 3 yellow. So they had a total of 20 spins. Okay? So what's the probability based upon this that I'm going to get a red? 5 out of 20. What's the probability I'm going to get a green or a blue? 12 out of 20. And what's the probability that it's not yellow? 17 out of 20. Now, which one has the same experimental probability as theoretical probability? Well, the theoretical probability, assuming that all 4 sectors are the same size, which they are, the theoretical probability of all of these is 1/4. I've got a 1/4 chance that each color comes up. The only one that has the same is red, because my 1/4 equals the 5 out of 20. Okay? So those are the basics of probability, and we will keep building on this throughout the unit.